Okay, let's take a look at the one-factor ANOVA. What I've got here is I've been taking data on machine 1, machine 2, machine 3. I've also recorded their shift. We're not going to use this column yet. I just kept it there so you can see the difference when we get into the two-factor. So I'm going to worry about machine 1, machine 2, machine 3. And my null hypothesis would be that the variance of 1 is equal to the variance of 2 is equal to the variance of 3. I think in the video, the guy said the means. No, it's the variance, not the means. If you want to look him up and scold him, he got it wrong. But the point is that there's no difference between these three machines. So how do I analyze this? Well, I come in here and I'm going to come into data. Come over to data analysis. And again, I showed you how to download this on the tool pack. If you have questions, ask. I'm going to click on that. And then right up here is ANOVA single factor. I'm going to click on that. And the input range is right there. It's grouped by columns. I'm going to put labels in first row. And I'm going to change this alpha. And instead of being 0.05, let's make it 0.01. So there's only a 1% chance I'm going to get this wrong. Okay? Output range. And I'm just going to put it right there. Click on OK. Get this so we can read it. So what happens is, here's machine 1. It does our count. 15 looks at it. 15 looks at 2. 15 looks at 3. It adds up the total, and you can check that yourself. It takes the average and also calculates the variance, the square of the standard deviation. Okay, so I'm looking at the source of variation between groups. So there's variation here and here. So there's 2 degrees of freedom. And sum of squares basically just take all of these and, well, I won't get into it. I'll let you look that up yourself. And within groups, I got 42. And I can't remember. I think it's like you take the number of groups times the number of looks minus 1, so it should be about 3 times 14. And I don't know, I can't remember why that it works that way. I'm too lazy to figure it out, too lazy to look it up, but just take my word for it. Excel does this for us. I'm okay with that. So then it calculates my F statistic, okay? And then it comes in here and it says, okay, what's my F critical? And again, this is based on the 0.05 or 0.01 alpha I did. So remember our hypothesis here that there's no difference. But remember I was saying if P is low, HO must go. And you can see it's pretty low. Let me put that in a format that looks familiar to us. Number. I want number, and I'm just going to. Right. So our p-value is very, very low. Let me go over here a little bit. P-value is very, very low. So what I'm saying is, or what this is telling us is, the difference between the different machines is almost certainly not caused by random chance. Therefore, if HO is low, or if our P is low, HO must go. We reject the null hypothesis and take on the alternative hypothesis. There is a difference. So now we can start looking for this. And I want to discuss, why don't we use the t-value or t-test on this? Why can't we use the t-test on this? And I'll leave that up to you. I'll be in the discussion. So.